Assalamualaikum and good day. Okay, let's look at a few examples on related rates. Okay, the first one is this question, this problem. It will be a hot air balloon rises at the rate of 7 feet per second. Okay, from a point on the ground which is 50 feet from an observer. And we need to find the rate of change of the angle of elevation from the ground when the balloon is 20 feet above the ground. Okay, for this type of question problems, it is suggested, okay, for you to actually sketch. Okay, so right now what we can do is, okay, let's say this is a balloon, okay, and it rises up from the ground. Oops. Okay, rises from the ground. Okay, so the dHdt, let's label it as H here. So dHdt is equal to 7 feet per second. Okay, and next, a person is here, observer, and it is said here that the change of the angle of elevation from the ground. So that means, let's say that's where the balloon is. We need to find here the theta. Okay. So next, we do know that this is 50 feet. Okay, from this figure, we can actually create a function. Okay, write a function. As you can see, this is the sides, both sides. Okay, what we can relate is with theta by using trigonometry. It will be, let's say this one is H. So H over 50 is equal to tangent theta, where H is equal to 50 tangent theta. Okay, and from the question, what are we going to determine actually? The rate of change of the angle of elevation. So we want to determine d theta over dt when H is 20 feet. Okay, so d theta over dt. So we need to differentiate both sides with respect to t. Okay, this will be implicit differentiation. Okay, this one is differentiate both sides with respect to t. H, and here is differentiate with respect to t. 50 tangent theta. So here we have dh over dt because differentiate h is equal to 1. And differentiate this term, we have 50 secant squared theta d theta over dt. Okay, next, we want to find d theta over dt. So rearrange, we have d theta over dt is equal to 1 over 50 secant squared theta times dh over dt. Okay, change it into secant is 1 over cos. So here it should be cos squared theta divided by 50 times dh over dt. So right now, we need to determine what is cos theta. Okay, from this triangle here, we know that to determine cos theta, it will be h over the hypotenuse. Let's say we name the hypotenuse as c. Okay, so right now, we know that h is actually currently equal to 20 feet. But we don't know what is c. So using Pythagoras theorem, we can find the value of c. Okay, it is actually c squared is equal to 50 squared because this one is fixed. Okay, because the observer is static 50 feet from the balloon. Okay, so 50 squared plus 20 squared, and then c is equal to root of, let's calculate, 50 squared times 20 squared is actually 2900. Okay, and here it will be root of 2900 is 53.852. 53.852 feet actually. Okay, 53.852. So here cos theta is actually opposite over hypotenuse. Cos theta is actually adjacent over hypotenuse. Okay, so here it will be cos theta squared is, Okay, let me change the pen first. Cos theta squared is 50 over 53.852, because this one is square, so that means the value need to be square. Okay, multiply times again and times 1 over 50. dH over dt is 7. Okay, calculate them all together. We have 50 squared over 53.852 squared divide by 7 times, divide by 50 times 7, and the answer will come out to be, it is 0.121 radian per second. Okay, take note, the answer that we get actually for the angle of elevation would be in radian, not degree. It is radian. Okay, so this would be the final answer then. Okay, 0.121 radian per second. Okay, let's look at another one. Okay, here a tank is being filled with the brine at a rate of 10 meter cube per second, and the radius of the tank is 12 meters and the height of the tank is 8 meters. So, at what rate is the depth of the water in the tank changing when the radius of the top of the water is 6 meters? Okay, so right now the tank is actually fixed. Okay, it doesn't change. That means the tank is like this, for example. Okay, the radius is fixed. That means the size of the tank is actually, the radius is 12. And the height here is actually 8. Okay, even though my drawing is not accurate, just imagine. Okay, and then from here we can actually that means when we fill in the water, the radius and the height change according to the water being filled in. Okay, let's say at this height, okay, this is the radius and this is the height at the current level. Okay, so we need to determine the ratio. Okay, because the water level and the radius changing according to the ratio of the size of the cone. Okay, so right now we have R over H. Okay, radius over height is equal to, the radius is 12 and the height is 8. So R is equal to, this one can be simplified into 12 divided by 4 is 3. So 3 over 2 H, we have this one. Okay, and then we need to find the rate of the depth of the water. That means we want to find dH over dt. Okay, when R is equal to 6. Okay, by right, when we want to find dH over dt, our V, equation of V, volume, should be in terms of H only. Okay, so we need to use this ratio and substitute in our V. So V is equal to 1 over 3 pi r squared h. Why do I use V? Okay, let's look at this first. The given value to us is actually dV dt. dV dt is equal to 10 meter cube per second. Okay, and we want to find dH over dt. That means here we need to have dH over something times something over dt. Okay, since we have the value of dV over dt, so that's why this should be dV. The place here should be dV, because when we cancel out using chain rule, we'll have dH over dt back. Okay, so right now, in order to determine dH over dV, we first determine dV over dH first. Okay, to get dV over dH, V must be in terms of H only. Okay, so right now it will be 1 over 3 pi, R is 3 over 2H squared. Okay, remember, square there, times H, where V is equal to 3 squared is 9 divided by 3 is 3. So 3 pi H cube over 4. Okay, next, dV over dH. dV over dH means we did differentiate the V that we have, okay, in terms of H with respect to H. Okay, and this will be 9 over 4 pi H squared. Okay. Next, dH over dV is equal to 4 over 9 pi h squared. Okay. Hence, we have here dH over dt is equal to 4 over 9 pi h squared. Okay, because refer to here dH over dV times dV over dt, and the dV over dt is 10. So here times 10, which is 40 over 9 pi h squared. Okay, we need to find dH dt when r equal to 6. Okay, but here we have the h, right? So what you have two options. The first one, you can find the value of h when r is equal to 6, and the other one we just substitute 3 over 2h here. Okay, it's up to you, but for me the easiest thing to do is actually calculate for h. So we have r equal to 3 over 2h, which means h is equal to 2 over 3r. H is equal to 2 over 3 when r is equal to 6. So h is equal to 316 is to 4. Okay. So here dH dt when h equal to 4. So 40 over 9 pi 4 squared. And it will be, okay, let's calculate together. 40 divided by 9 pi 16. So the answer here is actually 0.0884, and the unit, make sure you write the unit. It is meter, so meter per second. Okay, that's it. That's what you need to do to solve this type of question. Okay, hopefully you can grasp the understanding on these two, the concepts of these two type of problems, and see you in the next video. Have a nice day. Assalamualaikum.